This video summarizes a challenge-based learning unit taught in an AP Physics 2 class to 12th grade students at Indian Hill High School. The unit was created as part of the Research Experience for Teachers program through the University of Cincinnati. For the hook, students investigated disassembled, used laptop and power tool batteries. Each lab group recorded observations and questions they had about the disassembled battery packs for a class discussion. The students were then shown a YouTube video which discussed the reuse of individual lithium-ion cells to make do-it-yourself projects. After the hook, students were able to identify the big idea for the unit: energy storage and use. The essential question for investigation was, how could we recycle or reuse old battery packs which are no longer functional? The challenge for students was to design and implement a process to test individual lithium-ion cells to determine which cells have more usable life and which cells will need to be recycled. Some of the students' guiding questions included, what is a lithium-ion battery? What is usable life, and at what point is a battery considered dead? How can you determine how much charge there is in a battery? To answer these and other guiding questions, the students completed 2 lessons. Lesson 1 included both direct instruction and basic inquiry involving the fundamentals of chemical batteries. This included safety, charging and discharging limits, voltage ranges, and series and parallel combinations of individual battery cells. The first part of Lesson 2 enabled students to create a conceptual understanding of non-ideal chemical batteries, which involves the concepts of internal resistance and electromotive force. The students also developed a way to experimentally measure the internal resistance of a battery. The second part of Lesson 2 was the challenge, where students designed an evaluation process for used lithium-ion batteries. As an extension to this unit, the tested lithium-ion cells will be used to build small battery packs which can charge a cell phone or any USB-powered device. This will be something my students will look forward to doing after taking the AP exam in May. Throughout both lessons, students were given the opportunity to use the engineering design process to complete the challenge. Students were able to gather and identify information about the ideal performance of conventional lithium-ion batteries through the analysis of the manufacturer's testing documentation. From this documentation, students identified different criteria which could be used for their evaluation plan. Each student group selected 1 or 2 criteria they would measure about their used lithium-ion batteries to identify if the cells still had usable life or needed to be recycled. After their initial proposed evaluation process, student groups had opportunities to test and refine that process over several days. At the conclusion of the design process, student groups communicated their final solution through the creation of a digital document. This document included their final battery evaluation process, testing data and analysis, and refinements along the way. With the rise of electric vehicles and renewable power generation, electric energy storage is becoming a larger need within the transportation and power generation industries. Large battery packs using individual lithium-ion cells are commonly used for electric cars, personal electronics, and temporary storage for solar and wind power generation. Larger battery packs have a limited lifespan. However, since they're composed of multiple smaller cells, many of these individual cells are still functional and can be extracted and repurposed for extended life. Battery design and testing are related to the fields of chemical and electrical engineering. The use of materials which have a limited supply and lifespan should involve careful consideration when they reach the end of their usable life. Recycling the material or directly repurposing the material should be used whenever possible. This unit gives students the experience of finding ways to repurpose battery packs which were discarded and headed for recycling. I initially selected this unit to give students the experience of experimentally determining the internal resistance of a battery and to show them why it was relevant. The experiences they received throughout the unit implementation met both these goals. All student lab groups were able to determine their own method for estimating the internal resistance of a battery, and many of them were able to use that method to gauge the health of individual battery cells removed from laptop battery packs. It was so much fun to give my students such an authentic experience of problem solving, where the students had a voice in guiding the process, an opportunity for creativity, and a chance to experience failure, which leads to success.